the game actually got to name them. Big Boutte is a Highling cleric that we found in the game. It's a good name. And the fact that he has 69 hit points is a coincidence, but it's still a pretty funny coincidence. We've entered the code. Because of your superior intellect and diligence, you have saved Kron and all of its warrants. This ship, created by the ancients, is a grand experiment designed to populate this distant world. Prepare to beam down in Might and Magic 3. It's here, on the floor. I didn't see it. Thank you, my friends. You have banished chaos and rejected the false path of uncompromising order. Under the weight of the evidence and from the skilled pressure tactics of your lawyer, Lucas breaks down and admits to their crime. Congratulations, Ace. I think we're having a real moment here. I've changed my mind. I can't give her up. You can have your money back. How could I sell something so dear? And again, a deal's a deal, right? Right? Catch you later. Good luck. Enjoy. I'm out of here. Let's pick up the bottle of grog here. Pick up the root beer. Use the root beer with the jug. Apparently root beer works very well. We get to see an instant replay. And a view from the blimp as well. I wonder what would happen if I tore the leg off this thing. Ark.
You have a recipe? Madre de Dios! ¡Es el cuello diablo! Come on, I'm ready for you.
Yeah. Here it goes.
Enter visualization request.
Let's try it in the other order.
Subject code accepted. 6, 4, 5, 2, 3, 1. Recognized. Beginning message.
Grand experiment of the ancients to use the technology of elemental manipulation to create a completely viable ecological and social microcosm. This microcosm was then to be transported to a distant biosphere, Terra, to supplant its indigenous ecosystem. The need was acknowledged for a central controlling unit capable of compensating for expected anomalies.
Well struck. That looks like a fatal blow.
Yeah, die.
My death will not save you from our wrath.
Are you going to plug me into Link, sir? I hope you know what you're doing.
I have no idea what we're doing. And,
Something is happening, I think. Yes, I'm gaining control. I found my destiny, Mr. Foster.
goals in the middle. Perhaps you didn't even need to know that. The yellow crystal is over on the left side, and the blue one is on the right side. Switch to Annie, have her pull the lever to close the trapdoor, have her push the switch on this side, switch to Zack, have him push the switch on this side. On our way through this wall. Another mini boss. Good evening, welcome in. Why is it like this? There we go. Hey there, Josh, welcome in. I've spent a lot of time last week fighting this thing, sort of trying to get some sort of rough framework so we can start adding to it. Mostly I've been dealing with how to work around the various advantages and limitations of the BTC chip and the C128. It has interesting features and annoying limitations, as is probably the case with most any hardware. So there are obviously things that are pretty good about it. And then there are things that are just absolutely dreadful. And what I'm fighting with right now is some pretty simple code that is meant to draw a box on the screen, and next after that is the probably much more involved code that we'll have to deal with how we get fonts on the display. Yeah, but OBS keeps asking me to update. I can't say I'm I can't say I'm particularly excited about doing so. I'll do that in some other time, perhaps. Let's see if you can see some of the screen. No, you can't. Why is that? Why is that? No, V28 seems somewhat unready for consumption. This is not the overlay I want. this is, and where is my capture? There's my capture. There's my capture. Probably going to have to do something like this and this. And this. Yeah, it's been a tough week for me as well. We're being bought out by another company. So there's lots of turmoil. I'm fairly glad I can just focus on this stuff instead. And, the struggle right now is that just to go over what the problem is and what the problems are really. Yeah. The VTC is plenty weird. So the memory on the chip is completely linear, and you start at memory address 0. You can sort of adjust where it starts and move that around a bit if you want to double buffer or you have the memory to do so, but you start by default at 0. And the memory is totally linear, so you go row by row over the display. So in this particular case, this is 0, and this is 1, and this is 2, and so on. And then you go all the way to the end of the row. And when you reach the end of the row, all 60 rows that we currently have on the screen, you go to 61, which is then the first pixel in the next row. And to make this even more complicated, there's a fixed width. The width is always whatever width the font character that you're using is set to. Although this is a bitmap mode, this is really a text display chip. So the width is always 8, but the height is not. So in this bitmap mode, you have 8 rows of height, but only 60 rows across for the resolution over on this side. So you have 480 potential rows going downwards, but only 60 going across. And fitting things into memory this way is quite complicated. And when you want to draw something, it requires a lot of maneuvering around the memory to make sure that you're in the correct place when you're trying to draw something. And on top of that, there are other complications. Originally, I just wanted to use the text mode, but the text mode is very limited. In the text mode, you can only have one foreground color, and the foreground color goes across the entire display, but you can change the background color goes across the entire display, but you can change the foreground color for the text, but that's the only thing you can change. So it's pretty near to being monochrome, except you can change the text. It's not an Apple II, and the palette is okay. There are quite a few colors you can choose from, and you can because it's like CGA. You can also have some patterns and get some dithering, which introduces quite a lot of more colors. So it's colorful enough. That's not really the issue, but to be able to do something worthwhile, you sort of need to use the bitmap mode, and that also means that you lose the ability to just simply draw characters on the display. So one of the things I'm doing right now is I'm making this routine to draw a box on screen, and it can take a number of parameters. So it can draw a box that is this many pixels wide and this many pixels high, starting at any X or Y position, and having any color. And I have yet to enable the functionality to, but that's the plan, to have a title as well in the center of the top row. So the main game window will basically be comprised of a few of these bordered windows, one of which will be the main game area, and that's probably the area that we'll actually actively be talking into. Now, I played a lot, I spent a lot of time trying to figure out what the maximum resolution would be in the bitmap mode, because what we have currently is really 60 times 8 times 240, because you have 60 characters across, and then you have 8 lines per each row, and then you have 25 rows. So it's a 16 by 25 display that is taking up roughly 12K of RAM. The way it works is a total of 60 rows, and each row has 8 lines, so each row is basically using a few bytes, and then you can have 60 columns, I meant to say, and 25 rows. If you just multiply that together using simple math, it's 1500, but because there are 8 bytes per column, because you have 8 of these bitmap rows, you're using 12K of RAM, which is exactly 12,000 bytes that we're using for the display as such. And it's a pretty weird resolution. It's not a lot of resolution going across, but it's a pretty high resolution going downwards. And then you have a 48 byte padding, which is sort of required. Then you have something called attribute memory, which you can turn on or off. The attribute memory holds the background and foreground color in the bitmap mode, or just the foreground color if you're using it in the text mode. But if you are using it in text mode, you also have other facilities like underline and bold and blinking and so on that are not available in the bitmap mode. When you're using the attribute memory in the text mode, the upper 4 bits control things like the blink and the bold and the underline, and the lower 4 control the foreground color. But in the bitmap mode, this is background and this is foreground color. So that gives you a lot more flexibility as to what you can do. Obviously, you're limited by the columns, so each column can only have one background color, but you have quite a bit of resolution inside it. So you can make up a pretty pattern for it. Since you have 8 lines, you can basically have 1, 2, 3, 4, 5, 6, 7. I'm missing one. So the background color for all of this can be the same, and you can have a different foreground color, and you can choose to illuminate pixels in a way that makes up a pattern, and you can obviously change that on the next cell next to it. So you have quite a few options there. Now, the attribute memory is on a text basis, since it affects the entire cell. So that only takes 60 by 25. There is no other you can't change it any more than that. So that takes exactly 1500 bytes. And when we're done with that, we're using 1248 plus 1500. We are using 13,548 bytes of RAM, which leaves us with 2,836 bytes to be used for other things. And obviously we're going to have, that's going to be very tight, because the weirdest thing about the chip is that the only way to access the chip is through two registers on the 128 side. It has its own memory, which is not bankable, so you can't access it directly. So the way you access it is that you send a command to the control register and tell it that you want to talk to a certain register on the chip. Then you have to wait for the chip to be ready to accept something in the value register. And the way you check that is you check for bit 7 on the status register, which is at the same location. So you write to it and then you read from it until the bit is set. And then you can write a value into it. And this is all fine and dandy for just setting things up, but for copying large amount of data, this is very slow. So if we want to keep something graphically heavy in the main RAM of the C128, that's going to be very difficult to do. We can swap things in and out during something like a loading period and so on, but effectively moving large blocks of memory from the C128 side to the on-chip memory or the separate memory is going to be dreadfully slow. On the other end, however, the chip has two features which are very handy for dealing with this. One is the fill feature, which basically means that you write a single byte and you can tell the chip to copy the byte as many times as you want, up to 256 times. So that's very useful for things like clearing. If you want to clear the display, you can do that in just a few commands and the chip will take care of the rest. And since the chip is running at something like 16 megahertz, you can basically update the entire display at something like almost 15 frames per second using just the copy mode. And then there's also a copy block mode, which is more useful if you want to copy something from another part of the chip memory and into the current display. So you can have something stashed away in the free RAM that you have, and you can tell it that you want to copy from this particular memory location on the chip to another location and then just have it go away at it. So if you have what you need to do inside the chip, inside the memory of the chip, you can leave that to its work while you're busy doing other things with the CPU. You can leave the chip doing the copying while you do something else. And if you're working in a low enough resolution, you could potentially double buffer as well. You could create or make up a secondary screen in another part of the memory location and then swap them back and forth. But to do that, we would need double the RAM. Funnily enough, the default 128 setting is 16K, but the later models had 64K, and there are upgrade chips available to upgrade all of them to 64K. So you can pretty easily have 64K of this memory, which opens up a lot of doors for increased resolution and doing further things with the chip. But I like being limited to the 16K. Let's see where it takes us, what we're able to do with it. I haven't gotten... It has the 16K or 64K of the dedicated VRAM for this particular chip, and this chip is only really used when you address it as such. And we swap over to the set this up properly here. this is the wrong screen. They both have the same name. It's sort of amusing. It might actually be a problem. That might actually turn out to be a problem. Let's see if we can catch the other one as well. No, it can't catch the other one. I wonder if we can change the name of the window. Maybe we're better off using C64K as an emulator. Let me set it up really quickly here. Open up both of the displays. They're not named the same, so that's a plus. See, this is this display. This is the other one. I wonder if you can change this annoying behavior that this application has to show the speed of the emulation as a part of the window title. That's not going to work very well. OBS doesn't like that at all. When it keeps changing the title of the window. There this one is. Doubt it works for more than a few seconds. Let's see if we can get this loaded up. So I can at least show you a little bit of what we have or what we don't have really. Still very early days. Now this little program called Set64K comes recommended by people familiar with developing for this chip because apparently it's more cycle exact and emulates the VTC better than than Wise does, but according to what I've read, there's been a lot of the recent development on the C120 or on the Wise for the VTC chip, so it's probably getting to be on par at least. This is what we currently have on the VTC display. This is my little box. I'm trying to close these gaps here. The line at the top isn't full height. I'm trying to keep it so that we can have the text directly under. So it's basically 2 blank lines, then 3 lines of the border, and then another 2 blank. And then I'm using the background color feature of the attribute to draw the border on the sides because it needs to be 8 pixels white anyway. So I'm just using the attributes there. I don't actually need to draw anything on screen. So that's sort of handy if you want to just fill out an entire block of color. It's much cheaper memory and CPU wise to just do it with the attributes. And then I have the bottom border, which is similar. It has 3 lines of a fill and 2 empty lines, and 3 above and 3 below. So this will eventually make up a box, and what's next is to sort of add this add the final bits here. It needs to match, so there need to be borders here on the 2 empty lines below and the 2 empty lines above here as well, so that the border closes up, and I need to finish up making the border on this side, but otherwise the box code is largely complete. And then I have to test it with different sizes of boxes and so on, and it's just something I can do on my own. What I sort of wanted to do tonight was to see if we can't get some text displayed on screen, because that's going to be a major hassle. One of the problems of changing over to the bitmap mode is that we no longer have the characters in RAM, which it's not great, and due to the way that the memory is aligned as well, drawing characters is going to be a massive pain in the ass. The cheapest way in terms of CPU in doing this is to go a row at a time, because then you can use the copy feature. Then you can draw the top row, and then once you have the top row set, you can set the source, then copy the bottom row. But doing that with text is going to be a major pain. So I'm going to have to think about the best way of approaching that, really. What would be the fastest ways to approach that? Because if there are 2 things certain in this game, one is that the view window needs to move at a pace which is not unbearable. It's not an FPS. It doesn't need to be running at 50 frames per second, but it can't be so slow that you can take a coffee break while you move around or turn. And the other thing is that we're going to have to be able to display a lot of text. That's and that needs to happen reasonably quickly. So I'm curious as to what we could do with that. So one thing I wanted to do now was to see if I don't have some bitmap font that I've already purchased as an asset in my itch.io collection. I probably do. Seems very unlikely that I don't. Yeah, I seem to have something here. Thank you, Josh. I'll see you later. I need something that has a bitmap file. Let's see what this looks like here. The font really needs to be an 8x8. Going through what I have. I don't really care what it looks like at the moment. Getting the code working is sort of one thing, and finding something that works perfectly is another. An 8x8 font is an 8x8 font. We can replace the data in the font at any point, so that's not particularly important. This looks like an 8x8. With upper and lower. Or it seems to be slightly more. Search by title. Let's see. Yeah, we're doing these dev streams. Sort of had this idea of I don't know if you were here last Wednesday. I sort of had this idea of developing a role-playing game for the Commodore 128, and we've just started. The game is this is the current game window. It's broken, and task for tonight is to try to see if we can find a font, load the font, and get some characters displayed on the screen, which is quite a task. Probably won't get to the end, but we'll see. Here's a font. There's a font sale over on HIO. Best buy a few fonts. Support indie developers. It's the price they charge for some of these things is very low, so we can try some of them out. This one actually looks pretty good, and what's more important, it has a PNG version, which we need. Let's zoom in a little bit here. Yeah, that seems about right. There seems to be a pretty even space between them. They're all in a box. See if I can get this pictured for you. This is what the font looks like. It's an all caps kind of font, but it has capitals and smaller letters as well, but they're all in caps. Doesn't really matter very much. We just need something that we can actually use, and we need it in a PNG format so we can actually work with it. And we need some way of getting it into some sort of file as well. That's one thing. Split over to something like this. What is this like? Yeah, it's Mount E. There we are. There we are. I see that we can't see the bottom here. That's very nice. Why is that? I'm cropping something here. Let's not. Let us not. I can also expand it a little bit here. We are. Let's see if we can't figure out how to do this. Let's get this file over into that folder. Probably want to make some sort of folder called data. Okay. A file here called ch.png. Let's keep it lowercase. There we go. No. Funny how Windows does this. If I remove it and copy it again, it actually obeys and puts it into lowercase, but otherwise it just stays the way it is, and even if you copy something over it, it stays with the original file name. Sort of funny how that's handled. I'm going to need sudo apt install aptitude. Lib png devil is probably what we want. And probably install all the what is it complaining about? Yeah, it got what it really needed. Do I have a compiler? No. I do need a compiler. PNG dev. Yes. GCC. Have a compiler. Altitude. We're going to need make as well. Or maybe we need it, maybe we don't. Okay. Let's see. We're gonna need at least standard input output. Probably standard lib as well. I'll need some sort of buffer, right? Set some reasonable limit here. Malloc 16K here. Check if we actually got one. And we're going to have to open a file. Going to need parameters as well. Open the first parameter. We only need read. And we're going to have to open up another file called font.dat, which is going to be right. Call this in. We'll call this out. Make things slightly easier for us. Oh, if we can't open the in file. We need to do something about that. Should free the memory before we return. We can't open the out file. Now we have to close the file as well. Otherwise, if we make it to here, we have opened up both of the files, which is nice. Now, red bytes is going to be freed from the buffer. That's the parameter to this again. We'll read 8 bytes at a time, up to max size from in. Read, tell the user that we read X bytes. And we need to close the in file, close the out file, free the buffer, and return 0. Number. We haven't done anything yet. But, it's a skeleton. Hey there, I'm Kaluya. Welcome in. Forgot the second parameter. That's not allowed, is it? What I meant to say was this. Forgot one semicolon here. And it compiled. Read 283 bytes from ch.png. Okay. We're halfway there. What we're trying to do is write a little program that will extract data from this file that I have here, which is a file I purchased from itch.io. It's basically a bitmap font because I need it in a format I can use with this game that we're trying to develop. And, I'm going to have to figure out exactly how many pixels I can get away with. Let's see if I can open this in something that is more pixel friendly. So there's going to be some pixel counting involved. That's way better. As a ruler. So also has grid lines. Paint is it's better than it sort of looks. Where is this? Here it is. So it has grid lines, which is pretty great. So the block is here, and the font obviously starts here. It seems that this is at 1. This is at 5. So the box itself is 8 characters. But the font is not centered inside of the box. Let me drag this here so it doesn't do this. There we go. The font isn't centered. Hey there, bloody characters, welcome in. So all we really need to do is need to read here from fairly sure it stops. Oh, it doesn't. One point doesn't extend slightly further. I think the largest character is this. Starts at 1, extends to the last active pixel is at 6. So we need to read 1, 2, 3, 4, 5, 6, and that leaves a single space on both ends. So that makes it 8. It's the same, I suspect, with the height, except there we don't need to put anything. This is 1, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. Here we don't need to put anything, so all we really need to do is make a single byte here before we start copying things over. I will make it move it over here. Let's see what happens if we this is not the file that I have in there. This is a copy of the file. I can deal with this however I like without modifying what we already have. I suspect this is roughly what we want. If we were to take something like this letter here, which is slightly larger. This is what it would look like. Yeah, that seems about right. Of course, to save ourselves a little bit of work, we could just do this for every letter. And to be absolutely clear, I also don't want every letter. But we don't have an endless amount of space, and we certainly don't have abundant video RAM. So We want as few things in memory as we possibly can, which means that we want the block letters and the smaller letters, and we want the figures, the numbers, the numerics, and we want some of the symbols. Probably not all of them. I'm not sure either exactly how we're going to arrange them in memory to make copying them as easy as possible, because that's going to be a chore as well. The memory alignment on the chip is such that writing the characters to screen is a major hassle. Sort of looks better like this. Yeah, I'm aware of the fact that they have differing amounts of memory. You can get an upgrade, and most of the emulators support the 16K as well, but I'm sort of aiming for the 16K with the bitmap screen that I have in place right now, which basically just, as you saw probably earlier, only really has the single box on screen at the moment. The display is in resolution wise, it's 480 by 240. Column wise, it's 60 columns by 25 rows, and based on the calculations that I showed earlier, it takes exactly 12,000 bytes of RAM, not 12K, but 12,000 even. And there's a little bit of padding, and then I'm using the attributes as well, which take another 16 by 25 bytes, which is 1,500 bytes. So in total, we're using something like 13.5K. So we do have something like nearly 3K available, which doesn't sound like a lot, but it's still a decent chunk. We still have to fit tiles that we want to use for the main game display. They sort of need to be in the VTC RAM if we want to copy them, be able to copy them over. If they're the main memory, then access to the VTC is complicated enough that copying it from main memory is it's going to be fine for something like something static, like a single display picture or something like that. But for something that is we need to move around, that's going to be too slow. At least that's my guess for a majority of things. So the characters at least need to be. Characters need to be on the chip, and the tile setup we're using needs to be on the chip, and everything else is sort of expandable. If we move to text mode, then obviously we gain a lot of RAM, but we also lose a lot of color. We lose the ability to have a foreground and a background color on the same tile, and that sort of ruins the experience. So I'm going to try for the bitmap mode first, and this is also just a proof of concept and fun in games as well. We might never complete this game, but it's still fun to try. I've had lots of fun this week just working on some random utility assembly routines. I found a very good routine for multiplication, which is one of the things that the 6502 just doesn't do out of the box. So you need a routine that does it for you using shifters and addition. I also found a decently good dividing routine. We don't really need very complicated multiplication or divide. It's just two 8-bit products and one 8-bit result. Or in the case of the multiplication, I do need two 8-bit inputs, and I need a 16-bit result as well. So the multiplication supports 16-bit. And then I've written routines to find out the coordinates on the screen and print the box and initialize the BTC chip and set it up correctly, set all the registers correctly. It took me ages to find all the information I needed to be able to do that as well. This is all fun. I have the main development code in Dropbox, so I can access it from both the Windows machine downstairs and the laptop. So if I want to work on it upstairs, I can do so, and if I want to work on it down here, I can do so as well. Yeah, this is a ton of fun, moving pixels around. I purchased this font on itch.io earlier. It's part of the font bundle that's on sale right now. It's probably not going to be the font, but welcome in Texas Foosball, by the way. It's probably not going to be the font that we end up using, but for development purposes, it's fine. Maybe we'll like it very much and just end up using it, who knows. The only problem here is that this isn't really meant to be used for pixel work like this, so the space that the program allows me to actually move the thing with is pretty small. It's only a 6x6, so actually getting a handle on it and being able to drag it around is tough. I do this for the letters that we're interested in, really. Come on, let me move you. I can use the keyboard. Very nice. I can, yes. There are actually there's a register that's used for that, and you can set and unset various options. So it's basically an entire byte. So you can have up to, theoretically, you can have up to 256 different memory configurations, of which Commodore actually recommends something like 16 of them. And I wrote a little macro called a set bank, which just fills out the relevant information, so you can just call it directly using a macro. I've been using macros quite a bit. They're very powerful. Save you a lot of typing work. So I've given some thought to that. I haven't really decided though exactly how we're going to do this, but I want to keep the kernel RAM in because I'm not interested in doing things like writing a routine to load and save from disk. So I want to keep the system routines in memory so I can just call them directly. I have no use for the basic ROM, so I can swap that out easily. I do need the I/O space because a VTC chip is accessed using in that space, so I need to keep that in. Can't bank that out. We're gonna have plenty of RAM available to us somehow. They made Might and Magic 2 work on a 64K C64, so I'm pretty sure we could make a fairly simple game like this using twice the RAM. You can sort of see what this font looks like. It has the smaller case and uppercase caps. It looks pretty nice. I'm making sure that it wasn't set a pixel lower. What I'm doing is I'm centering it in the box, so it's so we can just read it and map it directly. We could have, of course, just written a few extra lines of code to do this, but it seems like a nice and relaxing little exercise. This way I also get to see what it actually looks like, because I get to see what it looks like centered. So if it seems like it doesn't really fit one way or another, we can change it before we map it down. Let's see. Now we come to the premium stuff. There are 52 alphabetic letters, 26 caps, 26 lower. Then you of course have the 10 numbers, that's 62. Eight by 8 times 62 is you don't really need 8 bytes of RAM to store this though, because there's only one color. We need about half a kilobyte for 64 letters. So we can have symbols, but let's give some thought as to what symbols we might actually use. Definitely going to need an exclamation mark. And a question mark. Quotes. The ampersand. very likely they will need both the opening and closing brackets. That looks about right, doesn't it? Should I move this one slightly further in this direction? Is that about right? Yeah, it seems about right. The colon we will definitely need. Semicolon, not so much. Probably not a dollar sign either. Not a percentage sign. The single quote we will probably need. No, things like that bother me as well. But like in this case, the quote it needs to be somewhere, right? I'm trying to get them symmetrically spaced, yeah, because it bothers me. It really bothers me that they aren't. I'm wondering whether we need something more. I'm sort of leaning against having as little as humanly possible. And I don't really think we can get away with any less than this. Yeah, we're gonna need this as well. The slash, the simple forward slash. When you're displaying something, you have X out of X and so on. 5 out of 8. Yeah, we could do that as well if we end up in a... But I don't think that looks quite as nice. I think being able to have both does make it look quite a bit better. So we could sacrifice and gain another 256 bytes of RAM or so by doing that. We don't need the caret, not the backslash, not the tick, not the pipe. Don't need any of this stuff. So this is about it then. We could add one more character. Because then we have an even bracket of characters that we have. We're gonna need the plus. Plenty of things that have a +2, +3, +5, whatever. Then what I'm going to do is I'm going to take these suckers, move them here. Take these suckers and move them here. And take these suckers and move them here. I'm going to save this. I'm not going to cut the rest of the file away. There's really no need to do so. Fix this as well. The rest of the characters are down here, so we're only going to be basically using those 72 characters. That's right, 8, 16, 24, 32, 48, 56, 64, 72. That's 72 characters. 576 bytes of RAM. That leaves us about 2.34K. Gonna have to be conservative. Although we can save a lot of space in the tiles because some of them can just be blocks, and the blocks are easily handled with just the attributes. We can cheat quite a bit. If you only need a solid block, you can cheat quite a bit. There are ways to save RAM. Let me copy this file back over. Switch over here. Now we have the file. We know roughly how it's organized as well. Now we need to figure out how to extract this information and put it into a raw .dat file. I probably need to do I need to byte swap these? The wonders of Google is that you can look up example code for pretty much anything. Although I'm sure that many people claim it makes copy pasta code, it's also just a good idea. And if you go through it and understand what you're doing, zero harm in just borrowing code. It's already out there. What we need to do here is need to create a PNG struct P, which we'll call creatively PNG. This is a constant that's probably defined in the header file. And you can just pass it 3 nulls. Okay. Should probably just call abort here. It's probably a better idea. Do some error checking as well. Now let's actually read the file. And let's see what else we need to do. We've opened and created both the PNG struct and the PNG info struct. Both of which are arguments, it seems, to most of the functions in here. I don't think this is a compressed file, so I don't think we need a clip. That's probably good. This will back out if you're trying to reach something that actually isn't actually a PNG file, so that should be fine. PNG has a built-in abort function. You can override it if you want, but there is no particular need. We've already done the init IO. Some information that we don't actually need in this documentation. Maybe I should give you a view into that while I'm actually scrolling it. We're talking about alpha modes here. How we can superimpose images. Expand 1, 2, and 4-bit samples to bytes. It seems that the PNG file format is actually MSB. So you might be interested in doing this. Let's see if it's actually supported. Might not be. Find out a little bit later. We'll call it here though. What does transform expand mean? Oh, that's not what we want. We might want invert mono though. At the moment, the background is white. And that's sort of inverse of what we actually want. What we want is transform pack swap and probably invert mono. That's probably what we want. Might not actually work, we'll see. And then apparently the last parameter of PNG read PNG is just null. So the first is the pointer to the PNG struct, and the second is the pointer to the PNG info struct. The third is the transform, which is ORed. So we're ORed together, PNG transform pack swap and PNG transform invert mono, and then the last one is null. Now we've read this in. Now, after you've called PNG read PNG, you can retrieve the image data with row pointers PNG get rows, where row pointers is an array of pointers to the pixel data for each row. Okay, that's not terribly complicated. Let me switch back to the Ubuntu screen. I'll probably set up more overlays for this, so I don't have to keep manually swapping these back and forth, but we'll see. Okay, we're here. We read in the file, we've made the struct, we've initialized the IO and read the bytes in, and if things work okay, we've also used the read PNG with the transforms that we set. So what's row pointers in terms of what does that look like? That's a PNG byte P. Not byte me, byte P. See? Let's fit that somewhere up here. PNG row pointer. It's not ours. png byte p row pointer. What happened to my... Something happened. This console is completely dead. Thankfully, Vim is pretty good at keeping backups. We cover the backup right and then delete the backup. Where were we? Yeah, we were defining this. png byte p row pointer. And what I wanted to do, I wanted to go up here because we also need to type def something. I need to define what this is. It's pointed to a PNG byte. And a PNG byte is just an unsigned car pointer. Not sure we actually need to do this, whether it's in the header. This is just a byte. This is just a byte pointer. Let's see. What we get back is a list of pointers to the different rows. Row pointer is png get rows, png info. This should get all of the rows, make nice little pointers for us. call it a row pointer since it's actually a plural. We should probably unlock some memory for this as well. PNG malloc, PNG. How tall is the file? Not that we're actually going to need to read all of it, but useful to know how tall it is. This is the last byte. It's at 198. And this is 0. It's 199. So it's 199 times size of PNG by P. That should be enough. And then we can, of course, init all of this. Just null it. Before calling the function. And then we can allocate memory for the individual pointers as well. Now we need the width. Which is what? $73. With this 73, so it's 73 times the pixel size, which is only 1. And I recommend another function here. PNG set rows, PNG info, and the address to the row pointers. This might actually be a better idea. And we should be able to call it directly. Now, let's see what this actually looks like. Let's steal a function from the internet. Called print bits. It seems nice. Basically just seems to support every different size as well. And the various different types of pointers. All it does is just shift around things in a loop. And print the individual bits. That's going to be pretty useful to us. Let's see if we can actually do that here. See what this actually does. This might not actually work at all. Might segfault on us. Why is it complaining? What does it want? JMP BUP. Yeah. So this is really it's pointer. So there's a row and can you have multiple bytes in the same row as well? Probably you can, because of course these images can be up to 32-bit. And might need to cast this as well. What is it complaining about here? Why is it complaining over here as well? PNG byte PP. It's a pointer to a pointer. Oh, this is not correct here. This is something called a byte PP. Let's try this again. It compiled, but whether it crashes, that's a completely different thing. There's a read error. Of course, we have no idea what the read error actually is. I wonder how we can get closer to knowing what's going on here. Might be that some of these features aren't available. Let's try it without. We need to have something there. We can read this file, right? Yeah. The file is there. It's 8-bit. It's useful. So what we could potentially do is use the park swap, not so much the invert mono. That's maybe not an issue. Still doesn't work though. There's a way to debug, which is nice. Let's enable quite a bit of debug. See if that helps. Should be enough to do this. There's also a function like this. There's also something called PNG internal. This should be enough. This gave us no further information. It's not enough to just define it, at least. The problem with documentation like this is that it can be terribly outdated and changed, and that can be hard to find. For sure. I'm guessing that the only way to actually get this is to compile the entire library with the debug functionality enabled. Well, that's pretty difficult to do. Let's see here. Let's try a different method of doing this. Where exactly is it failing as well? Gets there at least. It's failing here. Yeah. This is the part that fails. Let's go over this. It's a PNG pointer. It's an info pointer. It's those transforms. And it's a null. Is it perhaps because we're not opening it? No, it's not the case. No, we don't need to read it in. We shouldn't have read it in fact. Might be our issue. Yeah. That's our issue. The testing code that we wrote to see if you could read the file. Interrupting with PNG reading the file. Okay. Packstrap was there. Somewhat interested to see if we can actually use this mono transform as well. Might not actually work though. It compiles, but who knows if it actually works. I would have expected to be able to see something here. What is the definition? Pragma of this. It's a PNG byte PP, which is technically exactly the same as this. How wide was it? It was like 73. Let's just see what's in this. Lots of stuff. All zeros. That's interesting. Why is that the case? Might as well just define it like this. I know exactly how long it's supposed to be. Let's see if we can't just call it like this. Skip this code. Same result though, right? Okay, this might not be doing us any favors since it's an 8-bit file. Maybe it doesn't pack strap either. Okay. Might not have done enough yet. I'm looking at some example code that I have from someone else. Does the init IO same way we're doing it here. What does this do? Insert the signature bytes in the file. Doubt that makes much of a difference. There's a warning there. Yeah, there was. There's an error there as well. PNG unsent integer out of range. It's probably this. This that it's complaining about. Stick to this for right now. Where is the warning or error coming from? This doesn't seem to sit well. Okay, we're getting some data now at least. That's nice. Now I'm interested in the park swap. Does it actually work? This is 10.10.0.101. Does it actually do what we want it to do? That's the question. It's useful if it does, not so much if it doesn't. This is the default, which basically does nothing. Can't see that it changes anything. Want to try the invert mono thing. See how that looks. I doubt it does much of anything either. But we can swap it on the way out. That's not really an issue. Yeah, it's basically the same with and without it. Yeah, of course the file is being, yeah, makes sense. I wonder if this works in this terminal. No, it doesn't. It does not. Does it work at all? It's really the question here. I suppose the shell is using what is the terminal? Should theoretically work. Should theoretically work. What we could do here, although it's a bad idea in a way, how many do we want? It's something like 1, 2, 3, 4, 5, 6, 7, 8 of roughly 10 by 10. Some of which are included with each, so it's 73 lines total. It's 9 per each, so we need 10 roughly. We want 2, 3, 4, 5, 6, 7, 8 of these. For each row, it's just going to need to be like this. Oh, it looks a little bit neater. This will be fine. Three, 4, 5, 6, 7. That's roughly what we want here. And what we want to do is this. Roughly like this. And yeah, this is a dumb way to do it. We want to pass it as an argument. To pass it as the last argument to the command. Yeah, I used to have some I have some pretty good native bitmap paint packages, but nothing that really is sort of used for this sort of thing. It's more of a sprite mapping kind of program. I'm sure I can find something that works pretty well. This is a Windows machine though. Okay, halfway there. Change this to asprintf instead. As usual. Let's remove this. This. What shit complaining about? Didn't close the bracket here. Now it crashes, which is good. I didn't do what we wanted it to do, but it did something. Now this should mostly work. Curious whether this actually works. Easy enough to just comment this out for now. Ah, yes, of course, there's only 1 byte. It's only 1 byte per line here. What we could do maybe even like this. What did it want? It wanted... It's just a warning though. I don't really need to do this either. We can just do this. Okay, we got some of that data at least. It's nice. Now we need to do something like this. What was the... Don't need to do this. We can... bitwise operators. Does this just work? No. Not directly. Chuto, right. Maybe we need to go through it bit by bit. Out of this loop, go back here. What happens here? Should still work though. Let's try just one of them to start with. There's no error at least. Amatabas. Need one more. I'm sure there are no errors in this code anywhere. Okay. Last one needs to have a new line. And then we need space between them. Not quite there. Little keyboard ASMR. The first one is fine. And it starts getting pretty freaky. Why is that? Why is the first one fine? Only seeing a subset of this because I'm not doing it inside the loop. I wanted to avoid the information overload. Let's move it here. The first one is perfectly fine. And it's just absolute nonsense after that. I can't see what's wrong with this code. Thirty-two 126 252 127 009. It's obviously nonsense. Is this supposed to be J? It's probably closer to the truth, right? Can't print quite this many per line. Sure what the best way to handle that would be. Maybe do it print 4 at a time, maybe. Maybe we can use the font size a little bit as well. I sort of wanted to sort of needs to fit into a single line. This might be too small to read. It's at least getting close to being too small to read. So very close to being able to fit it all on one screen. Now we can. We need more space between them, realistically. Need at least one more space. Maybe 2. We need a blank line after a pair. It's too much. That's close. It's not 8 though, it's 10. With 10 pixels of height. Need another new line. Roughly, they should all be the same. Maybe we're a little bit off with some of this. Why does this happen? Yeah, because it's 0. Getting there. This is not really the data that I'm expecting here. We should be reading this in on a row by row basis, and then on a position to position basis. And this should roughly be what we're looking at. So we should have this is 9. I would have expected the first one to be it's not in the same order though, is it? How is this being done here? Should be, right? This didn't work at all. It was a bunch of nonsense. if this is in the right order. And the first bit should of course be 0, which it doesn't become. It's not what happens here. It's like this, right? At least closer, I think. And it was. This way, if we go through it again, the first one will be 0. Second one will be 1. The third one will be 2, and so on. That makes sense. This, of course, only does 8 bytes at a time. This only does 8 bytes at a time. We definitely need more of these. Leaders need one more of these. We need one more of these as well. I could size reduce them by 1, but that doesn't really matter. We need to do this as well. Which means that the space needs to be interleaved, which is great. That's going to be fun. Are these all equally long now? Yes. Remove the last one. This one is slightly longer because it has to remove these and count them out. There are, it's each 9, so it's this one, 17, 18. It's this one, this one, this one, this one, this one, this one. Yeah, and then the rest. This would be 9, 9, 9, 9. 9, 999, 99 with balloons. That should be closer to the truth. Formatting to hell. Why? Because we had the space in between. This is porked for some reason. Now all of them are 1. Why is that? I'll take a better look at this when I've slept. I need my head to be functioning. When you're making mistakes like this, it means your head is stopped working properly. It's late, 1:30, time flies when you're having fun. Let's end this for now. I'll keep you posted in the Discord on the how we get along with this and how it goes. I'm having a ton of fun doing this. Thanks for coming in, guys. Thanks for chatting with me as well. It's been good. I'll switch to the end screen. But here, Wednesday, I have to pick an adventure game after we finish Day of the Tentacle. It's probably one of the later series LucasArts ones, but until then, later.